How do you solve the equation for x plus 8 over x squared minus x plus 1 is equal to x minus 4 over x? First thing that you want to do, you want to write all terms as fractions. So right now we have only two fractions, and we have the second one that we need to make a fraction as well. And then we will see what we can do using the LCD of the denominators. So you can write this as 4x plus 8 over x squared minus x plus 1 over 1 is equal to x minus 4 divided by x. Now that all of them are fractions, what I would do next is to factor the bottom here. Right? So we can write this as 4x plus 8 over x times x minus 1. Right? This is the factored form of x squared minus x. Plus 1 over 1 is equal to x minus 4 over x. So now notice that the LCD will be x times x minus 1. Because we already have x here, we have 1 here, and 1 goes together with absolutely anything, right? It's the most flexible fella around, right? So we can even disregard him, right? We can only compare x, this denominator, with this denominator. And we know that this denominator already has x, but this denominator is missing x minus 1, right? So the LCD should be x times x minus 1. So that means that this denominator will not change and this numerator won't change because it has the complete package already. But this fraction will change. It will receive both x times x minus 1 multiplied to the numerator and denominator. And only x minus 1 will be multiplied to the denominator and numerator of this fraction on the right side of this equation. Right? So what this looks like is this. Plus x times x minus 1 over x times x minus 1 is equal to x minus 4 times, and no longer x times x minus 1, but just x minus 1, because there's already an x there as part of the LCD. Right? So just x minus 1 is missing in the top and the bottom. Okay. So now that we have the same denominators, what this leads to is that we can combine the numerators of the fractions on the left side, right? So what it's going to give us is 4x plus 8 plus, and we can distribute this, x times x is x squared, and then minus x over x minus 1 is equal to, and we can play around with this using the FOIL method. First product x squared, then minus x, the outer and the inner, and then minus 4x, so that's the net of minus 5x. And then the last product is 4, right? Plus 4 over x times x. And notice that I didn't distribute this. You know why? Because it's the same denominator, right? The same denominator means that if you multiply both sides of this equation by x times x minus 1, you will have gotten rid of it, right? And we don't need it, essentially. Basically, what this means is that if we multiply both sides by x times x minus 1, right, and times x minus 1, we will get rid of these two, right? So as a result, the numerator of the left side is equal to the numerator of the right, and there's no more fraction, right? So we can just set this guy equal to that one. And notice that we have to start from the highest power of x in the decreasing order to make it look natural, right? So x squared comes first, and then there's there are like terms, minus x and plus 4x, so that's plus 3x, and then plus 8. And that is equal to x squared minus 5x plus 4, right? As simple as that. So as you can see, subtracting x squared on both sides lets that go. We no longer have that. So what I would do, I would add 5x on both sides now, because I want to have a positive coefficient of x and not a negative one. So I don't want to subtract 3x. Instead, I want to add 5x. And then I want to subtract 8 while I can. Right? Subtract 8 on both sides. What I would get is this. What I would get is 8x, and notice that this goes away and this goes away too, right? So 8x is equal to 4. Dividing both sides by 8 successfully solves for x. So x is going to be 1/2, right? That's the reduced version of 4/8. 1/2. I think I calculated this wrong. This should have been -4. So this is -4. So -4/8 gives us -1/2.